Hello everyone, I am ATHULYA GR, Assistant Professor, Department of Electronics and Communication, Vedavyasa Institute of Technology. Let me welcome you all to the today's Tech Talk section, Photonics. From the name Photonics, it is obviously clear that it is related to photons. And what actually are the photons? Photons are elementary particles of light or discrete bundles or quantums of electromagnetic energy. Therefore, any technology involving photons is called photonics, or it can be defined as the technology of generating, controlling and detecting light waves and photons. Now coming to the history of photonics. The word photonics is derived from the Greek word phos, meaning light. Photonics was coined as a field during the invention of laser in the year 1960. And the other development followed was the laser diode in the 1970s and the optical fibers which are used for transmitting information. Now let's see how photonics is related to optics. Optics is a general area of physics covering a wide range of topics related to the study of light, its behavior and properties. As you can see from the chart that photonics is a subset of optics discipline. Coming to the evolution of light, in the early 1060s, light was considered to travel in straight line. Ray optics is based on this concept. Later, in the 1080s, light was considered to move in electromagnetic waves. Wave optics emphasizes this theory of light. Coming to the next division of optics, modern optics deals with quantum mechanical properties of light. They are subdivided into quantum optics and photonics. Quantum optics is for fundamental research and photonics is for applied research and development uses. Next, we'll see the emerging fields related to photonics. Photonics is related to emerging science of quantum information and quantum optics, optoacoustics or photoacoustic imaging, optomechanics, optoatomics, polaritonics, programmable photonics. Optoacoustics is where laser energy delivered into biological tissues will be absorbed and converted into heat, leading to ultrasonic emission. Optomechanics involves the study of interaction between light and mechanical vibrations of mesoscopic or macroscopic subjects. Optoatomics integrates both photonic and atomic devices for optical applications such as precision timekeeping, navigation, metrology, etc. Polaritonics differs from photonics in a way that the fundamental information carrier in polaritonics is polarization. Polarization is a mixture of photons and phonons and differs in operation range. Programmable photonics studies the development of photonic circuits that can be reprogrammed to implement different functions in the same fashion as that of an electronic FPGA. Next, we'll see why do we need photonics instead of electronics. Photonic application uses photons in the same way electronic application uses electrons. Light can make devices like computer, mobile phones, medical instructors, etc. faster and more energy efficient. Light, it travels faster than electricity, so there is a big need to make things faster, which consumes less energy, smaller and cheaper. Replacing electrons with photons does all that. And secondly, you can say you can pack more wavelength into an optical fiber so that the transmission bandwidth is increased than a conventional copper wire. And light, it encounters no electromagnetic interference than that of an electron in copper wires. So these are the reasons why photonics can be preferred above electronics. Now coming to the application of photonics. Applications include all areas from everyday life to the most advanced science. Example, light detection, telecommunication, information processing, photonics computing, lighting, etc. There are economic as well as potential applications of photonics. Economic important applications include semiconductor photonic devices, fiber optical telecommunication, laser printing, optical data recordings, etc. Potential applications of photonics include chemical synthesis, medical diagnosis, on-chip data communication, sensors, laser defense, and fusion energy. So you can say that photonics has become an unavoidable part of our everyday life. First application, we'll see communication. In communication sector, display and miniature projectors, telecommunication fibers, optical communication fibers, etc. comes under photonics application. In the entertainment sector, the light that is shown in the parties, monument, decorative lightnings, all the consumer electronics displays in the smartphone, CD and DVDs, etc. comes under photonics applications. Now, environment and energy. Photovoltaic system made of semiconducting materials capture solar energy from the sun and convert it to electricity. Photovoltaic cells on a car can be used to power a fan and to keep car cool when parked in a heat. Photonic technologies are also important in maintaining a safer and greener environment. In the transportation sector, photonics can be used for traffic monitoring, for measuring macroscopic parameters of traffic condition, etc. It is used in sensors, head-up displays, lighting. In the healthcare sector, development in photonics can facilitate more precise detection of the diseases. It is used in the analysis of bacteria and life science applications, imaging of cancerous numerous cells, laser eye surgery, tattoo removal. It can also be used to analyze sugar levels in the blood through the skin. In the manufacturing field, laser technology has been a key in paving the way for automation in the manufacturing sector. Photonic technologies becomes vital in manufacturing semiconductors. In security, defense and rescue, photonic systems are used in airport security, biometric identity management system, border surveillance, etc. Advancement of photonics technology also is significant in producing smart weapons. It is also used to manufacture night vision devices, mine laying and detection, photonic gyroscopes, etc. Photonics is heavily used in agriculture. It is used in sensors and cameras on tractors, drones, etc. to enable soil and crop analysis. It is also used for sorting fruits. Light plays an important role in the growth of city farming. Using LED lights, vegetables and fruits can be grown in vertical farms to provide fresh and clean food to urbanization. With this, we can conclude the applications of photonics. Now, the disadvantages of photonics are: spurious reflections are more troublesome. It is expensive, harder to fix. Waveguides and fibers are harder to use than wires. To conclude the topic, we can say photonics is everywhere. It's a key enabling technology that can be found everywhere. Even if it is not a part of our everyday language, but it serves as a foundation for many technologies we depend on daily. Photonics, it makes the quality of our life way better and more exciting. Indeed, photonics is a technology with a very bright future. Thank you.